Find all vectors perpendicular to both A, which is 1, 2, minus 1, and B, which is 1, 0, minus 3. So we have two vectors. Basically, if you take the cross product, you should already know that the cross product, the result of a cross product of two vectors is another vector. What you probably don't know yet is that vector is perpendicular to the two vectors that you're finding the cross product of. That will be shown. We'll talk more about direction a bit later on. But the cross product of two vectors will give you a vector that is perpendicular to both. So if we take A cross B, then we should be able to find it will give us a vector that is perpendicular, and then we'll think about, well, what does this phrase all vectors mean? So firstly we start with the cross product. A cross B equals ijk. Vector A is 1, 2, minus 1, and B is 1, 0, minus 3. We put the straight lines to signify that we are finding the determinant. So this equals I times the determinant of, and then we just cover up the I column. That leaves 2, minus 1, 0, minus 3. And remember, it's minus j, always minus j. If we cover up j's row, that gives us 1, minus 1, 1, minus 3. And it's plus k. Cover up k's column, and we have 1, 2, 1, 0. Okay, just like that. So that equals I times 2 times minus 3 minus, always minus, minus 1 times 0. Minus j, and you've got 1 times minus 3 minus 1 times 1 plus k times 1 times 0 minus 2 times 1. Okay, so that equals I times, well, 2 times minus 3 is minus 6, 1 times 0 is 0, so it's plus 0, I guess. Minus 0 doesn't really matter. Minus j, and you've got 1 times minus 3 is minus 3, and then you've got minus, or 1 times 1 is 1. 1 times minus 1 is minus 1, so minus 3 minus 1, so minus 3 plus 1, plus k. 1 times 0 is 0, minus 2 times 1 is minus 2. So that equals minus 6i, minus 3 plus 1 is minus 2, so minus 2 times the minus j is plus 2j, and then you've got minus 2k. So A cross B equals minus 6, 2, minus 2. But that is one vector that is perpendicular to both A and B. But because we've been asked for all vectors, we can pull a factor out of this, and we're going to need to introduce a letter. Okay, so we could say this also equals, we can pull a minus 2 out of there. Minus 2 times 3 minus 1, 1. Okay, and to be fair, that minus 2, all it does, it dictates direction, and it just scales it up by 2. So actually we can replace this minus 2 really with a general scalar, k, we'll call it k, but you could really call it a lot of different letters. Certainly not A or B in this case, obviously. So vectors perpendicular to A and B, perpendicular to A and B have form, so we're going to write k times this simplified bit, so 3 minus 1, 1, and k is any real number really apart from 0, because if k was 0 you wouldn't have a vector, you'd just have a nothingness.